Okay. So, so now we can start with the next or presenting the slides, Avner. So let me introduce the next panelist. His name is Avner BEN-BASSAT, and he's the president and CEO of Plataine, and has a so probably Avner, you can present yourself, and if you want to start presenting, but probably we should wait until 20 minutes, so we stick to the timing. But if you want to do a brief introduction of yourself, I think now is the time.
It's okay, I can wait. Can you hear me okay?
Yeah, very good, thank you.
Okay, so I'm ready to start and I'm glad to be here. I can wait 1-2 more minutes to stay on time, no problem.
Okay, thank you.
So I think everything is ready on site. If you're ready, you can go ahead.
Oh, okay, super, fantastic. So good afternoon to everyone in Seoul and good morning if you are connecting from Europe. My name is Avner BEN-BASSAT. I want to talk to you about artificial intelligence and production scheduling in composites and how it helps to deal with the current dynamics of the industry. I was invited to speak at JEC in Seoul 2 years ago. It was a great pleasure. Of course, the world changed a lot since. I'm very happy and grateful to be here today again. And hopefully next year I can arrive in person once again and we can all meet each other. A few words about our company. We specialize in artificial intelligence and IoT software for manufacturing. We have a very strong practice and expertise in composites manufacturing. And our solutions are used today with very large OEMs and to very small suppliers. And I hope to share with you today some of the best practices that we have learned. Also, we are part of a community of partners, machine vendors, research organizations like NCC, CTC, Swinburne in Australia, and with also other software vendors like SAP and Siemens, for which we are very grateful for the relationship. And we're very proud of our awards, including one from JEC. So I'm very happy to bring our lessons learned today to this forum. So I want to talk about a few things. First of all, to explain our perspective on the current industry challenges, the vision for the digital factory, how you get there. Then I want to focus, and this is the main focus today, about scheduling and artificial intelligence. And then we will summarize and how we can always take it to the next level. So I'll be brief today in the interest of time, but if there are any questions, of course, we can have at the end, or of course, by email later on, offline. So what are we seeing today in the market? We are in touch with hundreds of companies in the composites area, from raw material suppliers to small fabricators, and all the way to the major OEMs. The general atmosphere is a quick ramp up, which of course is very optimistic and positive, especially for the single line. But there are also a lot of challenges that are making the management of production even more complicated. Fluctuations in demand and uncertainties. Are we at rate 50, 75, maybe 100? Raw material shortages and supply chain disruptions. A limited workforce. Can everyone arrive on site? Maybe one is in quarantine, maybe there's a factory lockdown. And many, many pressures that are making an already difficult task much harder. Our vision is for a factory that is digitized and connected and intelligent, where different employees, planners, supervisors on the production floor get different alerts, different recommendations from intelligent software that is connected to the production floor, that is knowing what's going on, and that is helping the manufacturing organization, reach the business goal, meeting rates, meeting on-time delivery, saving material, saving scrap, etc., etc. And what I'll discuss today is how we can reach this vision together and make a factory more digitized and more efficient. So there are 3 steps in the process. I will focus today mainly on the third one, but I want to talk first about the problem we're trying to solve. This is very important. You need to define what you're trying to solve and then put the technology in place. Now, for software to make intelligent decisions, for artificial intelligence, you need data. And the data will come from different sensors, machines, systems. Then you can use the data to analyze it. You can provide predictions and recommendations. But at the end of this, you really want to provide the optimization data. Now, we will talk later about the data collection, but the point is to collect the data that is relevant for your decision-making process, and not just to get all the data, because that's very expensive and very impractical. This is another way to look at it, also presenting the business perspective. As I discussed below, we want to get data. And the data will typically come in the manufacturing floor from 3 areas. One is IoT, sensors, machines, etc. They typically tell us the current status. Second is the other systems, the ERP, the PLM, the MES. And third is the operators with mobile devices or PCs, etc. First of all, you see here, all the data is digitized. It's not paper. Second, we're taking data from multiple sources. Actually, it's very important because the other systems today are siloed. They're locked in their own world, and they do not have the big picture. So we're trying to create the big picture. Typically, the ERP and PLM will tell us the plan. The sensors, the MES will tell us what is actually happening. And there's a lot of value for the input from the operators and their experience. So we put all the data in one place. We call it the digital context. That gives the software the ability to understand what is happening. For example, if the sensor tells us that the material is in this room, is it good or is it bad? Of course, it depends on many other factors, like the production plan, the material history, the temperature from the sensor, the machine status. So in order to understand if it's a good or bad thing, we need to have the big picture. And now that we established that, we can start making predictions. What is going to happen? There is going to be a production delay. There is going to be a quality failure. There is going to be a bottleneck, etc. If it's something bad, we can raise the alert, and then they can deal with it. But the best value for the business is achieved if we go beyond the alert and give the solution. And this is what I want to talk about today. So instead of just telling someone that they have a problem, for example, they're going to be delayed on the delivery, let's rearrange the schedule. Let's do job number 2 before number 3 and use machine number 4, etc. And maybe we need to reallocate materials, or maybe we need to change the tool maintenance schedule. So our goal is to reach this highest level of decision-making or decision support by the software in order to help the production team do a better job. So I want to talk about scheduling as one of the core areas of any factory. And I want to explain how AI can improve the scheduling process and bring a completely new level of production efficiency. And there are 4 core principles. One is to take a holistic approach. You need to look at the entire picture. The work orders, the customers, the resources, their constraints, the rules of the business, capacities, business KPIs, very important. If you look at only part of the picture, for example, you do not know the status of materials, then your scheduling decision will be less efficient. I will explain more. The second is the real-time approach. The production plan is created, then you want to track the status, and then you want to continuously re-optimize as the situation changes. So you want to be, of course, reactive, but you also want to be predictive and proactive. In many cases, you can address the issues even before they happen. We'll talk about that. The third aspect with artificial intelligence, we can have a learning system. We'll talk about that, how the system teaches itself to do scheduling in a given factory and continuously gets better. These solutions are not just mathematically optimal, but they're more practical to schedule because we're learning from history and we're also learning from the users. Very important. And of course, we want to plan on a continuous time horizon. We want to do long-term simulation for next year, next quarter, but also short-term execution for today, tomorrow, later this week. And then you want to continuously compare plan versus actual. So these are the 4 key principles, and I will give examples on each of them. So here you see an example of a scheduling Gantt chart. You see the different resources and the different tasks and all the dependencies. And as I said before, you want to look at everything. What you see here in the example is the fact that a given job is not just assigned to a station with a start and end time. We're also assigning the tool and the material. Now, why is this important? Let's say I create an incredible schedule, but I completely ignore the tool status. So maybe the schedule is impractical. Maybe there are no tools. And if I'm not thinking about materials, maybe they will expire too soon. So the ability to look at the big picture is critical. And we'll talk about the KPIs later. We are creating a schedule, the optimized holistic schedule. We're sending it to the production floor through digital screens, MES, whatever. Then we're tracking it. And now we are making predictions. What's going on? And if something bad is going on, we continuously re-optimize, as I explained before. Here's an example. Here, the system is learning the production patterns. It is predicting, for a number of reasons, that this job is going to be delayed in production. This is a machine learning capability. Now, first of all, we are raising the alert to the operators. And of course, now we are about to reschedule. But note the other side of this. We are aware of the material situation. So it's not just that the job is going to be late. The material will expire before the completion, which basically means we are now making scrap. So we have 2 problems to solve. So here you see the integrated approach of having the material information, which by the way are tracked with sensors, but also the AI capability to make this prediction. Now that we make this prediction, we can change the schedule. We can reallocate materials, etc., etc. The third principle is the learning system. And this is something very exciting that we announced a few weeks ago. We have an algorithm that teaches itself how to run a production schedule. In concept, this is very similar if you've read about artificial intelligence that is playing chess or Go. It teaches itself the different situations and then what is the best move in every situation. Now, of course, the number of situations is almost infinite or practically infinite. So there's an element of learning the different techniques and what works when. So the system is running different situations in the factory setup, of course, digitally, offline. And then it knows what to do in different cases, what to do when a new job comes in, what to do when a machine is down, what to do when a job is late. And it's very important here to understand the KPIs, because the decision of what to do, how to schedule, is very dependent on the business goals. Are we trying to maximize on-time delivery? Are we trying to maximize material costs or minimize? Are we trying to maximize OEE, etc.? So different KPIs in different situations are called for different decisions. And the system, it teaches itself and makes the recommendation for the planners. And all of this is fully automatic. Here, there's a strong emphasis on the executability, making a practical schedule. And this is where we learn from the users in areas which are not always practical to model in terms of the mathematics. But if the user is making changes to the schedule, we're starting to learn from them that they gave priority to a given customer, or that they added a buffer here, or that they changed the material allocation. Whatever changes the user made, if they're improving the KPIs, we learn from them, and the system gets better and better. What you see on the bottom is a glimpse of the learning capability, different algorithms with different tactics, and the different KPIs that they achieve, and you see the trade-off. This algorithm is very good on date compliance, but is very weak on resource utilization. But maybe this is important for the organization, it's fine. The thick lines actually represent hundreds of schedules, and what we're seeing is that different schedules can create similar results. So we know the KPIs of the business, and we teach ourselves what is the best way to approach every situation. So for those of you more familiar with the science of this is an integration of machine learning with search heuristics to create a highly optimal and highly practical production plan. The fourth element is the continuous time horizon. If you think about it, there are different decisions to be made for the long term, the midterm, and the short term. In the long term, we make decisions about hiring, procurement, ability to promise, ability to. So here we want to run a simulation. Should we buy another autoclave? What does it mean to open another, to hire more people? Can we promise rate 75, etc. In the midterm, it's too late to buy a new autoclave, but maybe we can change the shift or retrain staff or approve vacations. Maybe we can still buy material. And of course, for the short term, we have what we have, and we have to make the best use of it. So we, as a concept, argue that you need to continuously plan long-term, mid-term, short-term, and keep doing it on a rolling horizon, every day, every week. And test your decisions and make decisions. And of course, you want to use the same system for the simulation and the execution to make sure that whatever you simulated is actually practical to deliver. And of course, this connects to the previous principles of the integrated approach, holistic approach, learning system, etc. What you see here is an example of different scenarios. Each scenario has different scores in terms of the 4 KPIs that the planner selected. You see here visually what it means, and they can pick any of the scenarios and say, okay, this is what I want. What's a scenario? Different demand, rate 50, 60, 70, different mix, 7379, 737 MAX, different resources, more shifts, less shifts, another machine, less machine, and you can evaluate all these and make a business decision. Finally, I want to talk about how do you take this to production. Our experience and my recommendation is to take it gradually. First, test the value. Not just a technical POC, the technology works. You want to see what it does for you. What are your business KPIs, and if this technology, any technology, can help you. And during the proof of value, also evaluate the path to production, industrialization. And then roll it gradually from site to site, across the enterprise, and sometimes even to the supply chain. Do it gradually with the users, and then they also learn to accept and trust the system. So to summarize, we've talked about the current industry challenges, how digitization is even now critical more than ever. We spoke about the emphasis to reach the decision-making level and not just the data collection. You want to solve the problem, not only predict them. and then how to quantify the benefits and roll it out for maximized automation. So this is my presentation for today. I try to touch the main points, also in the interest of time. But of course, there are many more details behind this, and I'm very happy to share our experience. So if there are any questions now or later, I'm very happy to respond. Thank you very much.
Thank you very much for your presentation. And if there's any question or comment from the audience, please raise your hands. 혹시 질문이나 코멘트가 있으시면 손을 들어봐 주시면 저희가 마이크를 전달드리도록 하겠습니다.
If you raise your hand, we will hand you the mic.
없으실까요? No question from the audience neither. So thank you very much. 박수 한번 부탁드리겠습니다.
Thank you very much, everyone, and hope to see you soon. Thank you.